Welcome everyone. The
Welcome
question is
everyone.
a capacitor
The question
and an
is
inductor
a
are
capacitor and
connected
an
in
inductor
series
are connected
across an
in
AC
series
source of voltage
across an AC
of
source
variable
of
frequency.
voltage of variable
The frequency
frequency.
is increased
The
continuously.
frequencies
The
increase
nature of the circuit
continuously.
before and
The nature
after
of the circuit before
resonance
and
will
after
be inductive
resonance
only,
will be
capacitive
inductive
only,
only, capacitive
capacitive
only,
and inductive
capacitive
respectively.
and inductive
And option D is
respectively,
inductive
and
and
option D is
capacitive
inductive
respectively.
and capacitive
So two
respectively.
things are connected here.
So
Number
two
one,
things are connected
one
here.
is
Number
one
one,
inductor
number
is
one is
connected
one inductor is
of
connected there
inductance L, say,
of inductance L,
and a
say,
capacitor is connected
and
there
then capacitor
of
is connected
capacitance
there
C, say.
of capacitance C,
Now
say.
these two are connected
Now these two are
in the
connected
source of variable
in the
frequency.
source of variable
Let
frequency.
us say this
Okay.
source is written
Let us say this
drawn
source is written
by this
or
circuit
drawn
symbol.
by this circuit
This is our
symbol. This
variable
is our
AC voltage
variable
frequency. Okay.
AC voltage
Till
frequency.
now,
Okay. Till
till
now,
now we have basically
till
used
now
some
we have
AC
basically
source
used
whose
some
frequency
AC
is
source
fixed,
whose
but now
frequency
its
is
frequency is
fixed,
changing.
but now its frequency is changing.
Now,
Okay.
for a
Now,
particular frequency,
for a particular frequency, for a
or a single
particular
frequency,
or a single
what is the
frequency,
value
what is the
of
value of
reactance of
the
L?
reactance
For a
of L?
particular frequency,
For a particular frequency,
omega, reactance
omega,
of L,
reactance of
XL
L,
is omega L.
XL is omega L.
Reactance of capacitor
Reactance
is
of
1 by
capacitor is
omega
1
C.
by omega C.
So it is quite
So
evident that when omega
it
is
is
very
quite
small,
evident that when omega is very
then
small,
Xc is
then
dominating
Xc is
because omega is
dominating
kept in the
because
denominator
omega
of
is
Xc.
kept in the denominator of
But when
Xc.
omega is greater,
But when omega is
then
greater,
Xc
then
becomes less,
Xc
that is the
becomes
capacitive
less,
reactance
that
becomes
is the
less,
capacitive
and the
reactance becomes
inductive
less,
reactance becomes
and the
more.
inductive
So
reactance
we can
becomes
say
more.
when
We
omega
can
is
say when
very less,
omega is
then the
very
circuit is
less,
capacitive,
then the circuit is
the
capacitive,
circuit is
then the
capacitive
circuit is
because
capacitive
at that time X is dominating.
because at that time X is
When
dominating.
omega is more,
When omega is more,
then
okay,
the circuit will be
then
inductive one.
circuit will be
Then
inductive
the
one.
circuit will be inductive
Then
one.
the circuit will be
Then the
inductive one.
inductance is
Then
dominating.
the inductance is dominating.
So when the resonance occurs,
So when the
when the
resonance
resonance
occurs,
occurs, when the
okay, when the
XL
resonance
equal to
occurs,
XC.
when the XL equal to XC.
Resonance is a particular frequency
Resonance is
which
a
is basically
particular
say the omega naught.
frequency which is
When
basically say the
XL
omega
equal
naught.
to XC.
When XL equal to
Okay.
XC,
XL equal to
okay,
XC.
XL
That
equal
means
to
the
XC.
inductive reactance and the
That means
capacitive
the
reactance
inductive
becomes
reactance
equal.
and the capacitive reactance
Then
becomes equal.
omega L
Then
equal to
omega
1
L
by omega C.
equal to 1 by omega C.
So this is becomes
Okay.
omega
So
square
this is becomes
equal
omega
to
square
1 by
equal
LC.
to 1 by
So this
LC.
gives you omega equal
So
to
this
1
gives you
by
omega
root
equal
over
to
of
1
LC,
by root over of
and that is
LC,
my omega naught.
and that is my
Okay.
omega naught.
So when the
Okay.
frequency is less, when the
So when the
frequency is less
frequency is
than that
less,
of
when
the
the
resonant
frequency is less
frequency,
than that of the resonant
then
frequency,
what we have said before, when
then
the frequency
we
is
have
less,
what we have
then
said before, when the
Xc
frequency
equal
is
to
less,
1
then
by omega C
Xc equal to
will be
1
greater.
by omega C
The
will be
circuit is
greater.
capacitive.
The circuit is capacitive.
The circuit is capacitive.
The circuit is capacitive.
When omega equal to omega
When
naught,
omega equal to omega naught,
then XL
okay,
equal to
then
XC,
XL equal to
then it
XC,
is neither capacitive,
then it is neither
neither
capacitive, neither
capacitive
capacitive,
or nor
or
inductive.
nor
So
inductive.
it can't be neither capacitive
So
nor
it can't
inductive
be
because
neither
the
capacitive
impedances
nor
cancels
inductive
out each
because
other.
the impedances cancels out each other.
At that time, if the circuit have some
At that
resistance,
time, if the
just like
circuit
if the
have some
inductor that is
resistance, just
chosen
like if the
that have
inductor
some
that is
resistance, or the
chosen
capacitor is
that
there
have some
that have some
resistance, or the
resistance, then
capacitor is there
that
that have some
resistance is
resistance,
basically
then
comes in
that
for the
resistance is
cause of
basically
power
comes
loss.
in for the cause of power
But when
loss.
omega is greater,
But when omega is greater,
than omega naught, that is a
when
resonant
omega is greater than
frequency,
omega naught, that is a
then
resonant
XL
frequency,
equal to
then
omega L.
XL
That
equal
means
to omega L.
circuit becomes
That
inductive
means
then.
the circuit becomes inductive then.
Okay. So if you continuously
Okay.
increasing
So
the
if you
frequency,
continuously increasing the
we can say at
frequency,
first the circuit is
so you can say at
capacitive.
first the circuit is capacitive.
Okay. At first the circuit is
Okay.
capacitive.
At first the
Then
circuit
it
is
is transforms
capacitive.
into inductive.
Then it is transforms into
Okay.
inductive.
Then it transforms into
Okay. Then it
inductive.
transforms into inductive.
So according to options,
So according to
circuit cannot be
options,
inductive only.
circuit cannot be inductive only.
For the if you increase in
Okay.
frequency, it
For
cannot
the
be
if you
inductive
increase in
only.
frequency, it
Because
cannot be
since the
inductive
inductor
only.
capacitor both are
Because
present
since
there,
the
same
inductor
for the
capacitor
same
both are
reasons,
present there,
it
same for the
cannot be
same
capacitive
reasons,
only.
it cannot be
Okay.
capacitive only.
So it is
Okay.
capacitive then
So
inductive.
it is capacitive then
And the
inductive.
inductive then capacitive. Among
And
these
the
two options
inductive
we have
then
obtained
capacitive,
here.
among these two
If we
options we have
continuously
obtained here.
increasing the frequency,
If
it
we
will be at first
continuously increasing the
capacitive, then it
frequency, it will
becomes
be at first capacitive,
inductive.
then it becomes
So
inductive.
option C
So
is the correct
option
option.
C is the correct option here.
Thank you, Hannah.
Thank you all of you.